This is the Murders Creek Fuel Analysis Field Project. It took place in eastern Oregon. The site location is about 18 miles west of John Day, traveling along Highway 26 and then continuing down a Forest Service road south about 12 miles. The Murders Creek Work Study Cabin is on the south side of the road, just past there. The site is within the Malheur National Forest area. In 2016, the Murders Creek, portions of the Murders Creek area and Tex Creek had riparian areas, fences built around these areas. I picked this site location due to its uniqueness. Working in this area, helping to build these riparian fences, I observed many different types of wildlife in this area, and wild horses was one of those. The site is part of the Malheur National Forest, with the dominant tree species being ponderosa pine. In areas around there was limited tamarack and red fir were found, but none were found on site. The shrub understory included some snowberry in the surrounding area, red osier dogwood, and various willow species found along Murders Creek. Native grasses and forbs were present on this site. The area has open meadows and scattered trees and shrubs throughout the sample plots. Research has shown that precipitation comes year-round, but generally it's been noted, and I've seen, because I've frequented this area year-round, or most of the year, that generally November through April they receive most of their precipitation in the form of snow. And as I did the research, snow was found up higher than this location, but it had generally been melted off within this area. There was just one large patch of snow coming into the project site area about a mile back, but other than that, it was clear other than in upper elevations. Annual precipitation in this area is around 21 inches, and for the site analysis, temperature was at 51 degrees with scattered cumulus clouds. My objective was to gather field data from this local site and to utilize this fuel data gathered on site through established protocols and equations, and to use this data in order to gain further information for outputs and fire predictions, and then gain experience to be able to more efficiently make accurate fuel loads and recommendations for other sites in the future. Shrub and forb species that were found. As I mentioned earlier, there was snowberry. No snowberry was found actually on any of the plots that were in the sample area. There was red osier dogwood found along Murders Creek, but none was found on any of the sample plots. There were many different areas that had different willow species. There was various native grasses and forbs. And there was also ponderosa pine was a main species that was on this site, but these were just the shrub and forb species. In the top right photo, we see some various currant or a currant species, and in the bottom we see some blooming forbs. Tree species that were found in the site area were mainly a large ponderosa pine and a few small scattered ones. In some of the plots, we found that there was just only a couple of large ponderosa pine. There was very, very limited smaller stock, and what was found in ponderosa pine was around 6 feet or higher. And so based on the data, there was no, and based on observations and site analysis, there were no small, 1 to 2 feet or small seedlings that were coming in. There was also in one of the sites, there was a little bit of quaking aspen, which had some damage from, it looked like beaver damage, and so just very small quaking aspen coming out, nothing large, just a couple of diameters and inches. And then willow species, as mentioned earlier. And scattered in some of the areas and the surrounding areas noted coming into the sites, there was some scattered western juniper that was just very random and very scattered. These photos were taken from the Murders Creek site. The photo on the left is from the southern border of the site. It was actually off the site. It's along, you could just barely see a glimpse of Murders Creek in between the willows. And on the right is kind of a typical scenario for what some of the plots look like. Very scattered. I was surprised when I actually got into the sites and had them marked out. And as I went through the different plots that were selected randomly, that this is actually in the center of the site, and it just looked like there wasn't much larger stock in some of these sites. I have just put on this slide the weather codes that were used, and then the materials that were used for surveying. Wire flagging stakes, so that was to plot out for the staking the plot corners. These two teenagers that are noted were of great help in measuring the plots and for large tree measurements. A measuring wheel, measuring tape, string, a ruler, watch, a thermometer, a paper, pencil, and definitely the handbook for inventorying downed woody material was utilized before going to the site and on site, just to make sure that the protocols used for surveys were correct. These are the site descriptions of sample plots. Just shows that, some are more open meadow, the aspect of them, and kind of where they were located within the site. They all had a very small percent slope, and as noted, some of the site areas had more mature ponderosa pine, but there was very few. They'd be very scattered throughout the sites. This slide indicates the methods used to find fuel moisture. Relative humidity was gathered online. The temperature was recorded on site from my cell phone. And then the values were inputted based on a relative humidity, which was indicated at 40%. I did not use any fuel moisture sticks, and I used the Simard's formulas to figure the 1 hour and 10 hour time lag times. These are my calculations for figuring the fuel moisture values for the site. I had plugged these values into and did some estimations for percentages, and plugged these values into the Behave Fire model and came up that the flame length would be 4.1 based on the data that I had collected and had calculated. This is determining surface fuels for the site. This is what I used. I categorized the sampling flame lengths and fuel, the hour fuels. So the 1 hour, the 10 hour, the 100 hour, the sound 1,000 hour fuels, and the rotten 1,000 hour fuels. And then computed these into tons per acre using the formulas by Brown, 1974. The surface fuel data. The surface fuel data, this is what I gathered. It seems very skewed. The reason our 1 hour and 10 hour fuels, we have a pretty low amount, but as I looked through and went through and did the measurements, as indicated by Brown, how to do the samplings, I just didn't see a lot of small, fine surface fuels. And I believe the reason for that, after looking, it almost looked like everything had, almost like a fire had gone through, because there was so much that was limited. However, I didn't see any evidence of recent fire that would have gone through, that would have eliminated those small, fine fuels. But I did notice that there was a lot of wildlife. And so based on that, and based on it being along Murders Creek area where there is water, it is highly frequented by a herd of wild horses, and and elk and deer and other species that are in that area. Determining canopy fuels. I used the lookup tables from Brown and used the step-by-step instructions which were in the canopy fuels lecture. I went through that many times to make sure that I had the correct instructions and correct formulas. And so I used the lookup tables in Brown to get the data for the crown weights and foliage percentages, and then utilized the instructions in our canopy fuels lecture using the adjustment factors from Reinhardt. And then I converted, after I had the total biomass, and converted each, the foliage, the 1 hour, and the different fuel hour percentages. I put those into pounds and then converted those loadings into tons per acre, multiplying by how many trees per acre there was, and in some case individually figuring out the different trees and adding those together to come up with a number per acre, and then calculating per acre and tons per acre, and then use the foliage and the 1 hour, but half of the 10-hour fuels in order to come up with the total fuel loadings to give the available canopy fuel loadings. And from there, I computed the mean, the median, the standard error, and the standard deviation and variation through a online calculator. These are the results that I got from the canopy fuel loads. What I noticed is that there was a very small percentage of 1 hour fuels in a lot of the ponderosa pine due to the size. And even though there wasn't a lot of those larger trees, it affected the 1 hour fuels. And according to the Brown lookup tables, 1977, large ponderosa 1 hour fuels are very small, 0.01, compared to the total weight, so 1%. Data varied, as I realized, based on the number of ponderosa pines versus small diameter ponderosa, which yielded a larger percentage of 1 hour fuels. So in the smaller trees, there was more 1 hour fuels than in the larger trees. I found interesting that as I calculated the surface fuels, and in calculating the surface fuels, canopy fuels, and the fuel moisture, is that I didn't see, there was pretty limited surface fuels in a lot of these areas, small surface fuel loadings, but there wasn't a lot of small trees. And so what I gathered based on my data is that the reason that I had just some large trees or some smaller size ponderosa, 6 feet and up, but nothing that was really small, is that it would just look like a giant vacuum had sucked up all a lot of the surface fuels, is that there would have been cattle grazing. There was cattle in there this fall, and that would have had an impact. There's also wild horses and wild horse evidence recently in there due to piles of manure that were found, and also other wildlife. There's deer and elk frequent that area. Also, because of the winter, I believe that they would have been down on this lower area more. There was a lot more snow in the uplands, and so that might have affected the amount of area that they would have been, and also would have affected the surface fuels, and any small trees or shrubs that maybe would have had a chance had been eaten down. There was no evidence of any at all small stock of any species coming or growing. So ecosystem disturbances. So the two disturbances. One is the disturbance is wild horses, and that would affect the rate of spread because of the limited surface fuels. In the top right-hand corner, I photographed some lovely wild horse manure that was found in an area, but there was many piles found throughout some of the sites. This would have reduced the chance for a crown fire, and it would reduce the spreading and severity of a fire spread if a fire did start, just because of the limited surface fuel load. Also, the other element is that would be limited is the dry fuels were not only limited by the wild horses, but also beaver evidence. There was a few Quake green aspen, as noted earlier, that they were smaller stock, 3 to 4 inches, and they had been eaten down, cut off, and there was no evidence at all that any of those remained in the area. They were just completely gone. There was no surface fuels on the ground from those, and there was some pretty small diameter within, a couple of inches that were coming, or that were just starting to come as water shoots or root shoots coming up from where the original quaking aspen had been. And so also the cattle that had grazed there this fall, it looked like it had been grazed down fairly heavily because there just weren't the surface fuels or small stock of trees coming. And so I believe that was because of the wildlife and the cattle that had been in there. And so that's going to limit, without this adequate supply of 3 elements that are needed for fire, which is heat, fuel, and oxygen, fire can't start or sustain. So if it doesn't have the fuels, it's not going to sustain itself. And so I believe in this analysis that if a fire did start, it would not be a large threat, and there wouldn't be the damage done, very limited damage, just because it wouldn't be able to sustain itself very readily. Here are the references that I used, and a lot of good information also, which is not noted on here, came from our lectures, which I had reviewed and re-reviewed as I did this presentation. Thank you.